Hello everyone, welcome back to my channel Tech with Divyansu. I am going to explain of three fundamental concepts of operating system. First, round robin scheduling, context switching, and multi-threading. Let's divide up step by step. Okay, let's again. First, round robin. Okay, first round robin scheduling (RR). Okay, simple define a round robin is a CPU scheduling algorithm of design for time of sharing system. Okay, in this algorithm every process get a fixed amount of CPU time and called a time quantum time and slice. Okay, one more, a round robin is a CPU scheduling, okay, and design from the time sharing system. In this program vary and every process and get a fixed amount of CPU time called a time quantum slice. Okay, how it is work? Okay, first of all, how it is work? First, all economic of process are added to a read queue. Okay, then second, the CPU execute each of process from a fixed quantum. Third up, if a process and finish early to exist. Okay, and fourth, if it is not finished, it goes to back the end of the queue and a CPU move to the next process. Okay, suppose are primitively scheduling each up process is a given fixed times and slot. Okay, this time and quantum, okay, and process are kept in a circular queue. Okay, circular queue. When I process time quantum and expect it move to the back of the line. Okay, suppose a real life of example, imagine a single, okay, barista at a busy coffee shop and servicing and customer. Okay, first rules, the barista can be spent only 1 minute per customer. Okay, only 1 minute per customer. Suppose okay, then scenario, if okay, if your order and take 3 minutes, the barista works only your order for 1 minute, ask you to step aside to wait, service the next person for 1 minute and come back to you your later. Okay, the most of all goal of this of sentence, this scenario of no signal customer get a block, okay, blocked and waiting for your hug and order. Okay, suppose RR coffee. Okay, scenario, a busy coffee shop of barista and service a line of the customer. Okay, fixed time and quantum, the barista of a spend of extra and 2 minutes per customer order. Okay, all of the topic clear. Then next, impact of the time quantum of size. Okay, if quantum size too large and we have to like f. Okay, first come first serve. Okay, if a quantum tool is small, high context of switching overhead. Okay, then next of context switching. Okay, a context switching is the mechanism of a saving the state of a currently running process or thread so that it can be pushed can and restoring an another state to resume of execution later. Okay, this how it is work. First, the CPU save the current process and execution and context such, okay, as per program and counter register and memory and details. Suppose are into a process and control block. Okay, process control PCB. Okay, the CPU then loads the saved PCB of the next process into a memory. Okay, Third one, execution of resume. Okay, from the where the second process was the last post. Okay, first a note first a note first a note. Okay, context switching increases CPU overhead because the system of spend time saving and loading and data, and without our loading actual useful and progressing. Okay, then after a real life of example of context switching. Okay, imagine you are cooking a complex and replace while and studying for any exam. Okay, step first, you are reading a textbook to check the stove. You put off a bookmark in your book. Our write down where and stop. Okay, first switch. You walk over to try the put. Okay, and state two. First, when you return to study, you don't know, start from the page. Okay, you open the book and directly to your bookmark. Okay, na? The bookmark of act are like save and context of PCB. Okay, PCB of a progress control block. Okay, this is a real life example. Context switching of overhead and pure overhead cost, the CPU and performance, zero productive and execution work, and while and saving and a restoring of register into a memory cache of okay. Then again, hardware of dependency. Okay, the next of a multi-threading. A multi-threading, suppose a multi-threading is an execution model where a single process is divided into a smaller execution unit and called a threads. Okay, which run and currently and share the same memory space. Okay, one more, multi-threading execution model where a single process divided into a smaller execution unit is called a threads, which run currently and share the same memory space. Okay, how it is work. Okay, first up first a process create a multi-thread to handle different subtasks. Okay, simultaneously. Okay, all the threads share the same code and assign data assigned, okay, the operating system of resources. Third one, hours. Each the thread of a maintenance, it is one program and counter and register set and a stack. Okay, this leads to higher performance. Okay, and better of responsive. Okay, suppose a real life of example of imaging a okay commercial restaurant kitchen and preparing single dinner okay meal. This okay, first a process of cooking a dinner meals. Okay, a trade one a chief and chops and vegetable, a second chief and grills the meat, and a trade a chief of preparing the sauces, all the same kitchen and shared memory. Okay, because the work together at a same time. Okay, once more, because the work together at the same time, the meals get survived much faster than if one shifts and did everything and equivalent. Okay, okay, the one more, because the work together at the same time, the meals of get served up the much faster on the safe did not everything okay equivalent. Then again, okay, comparison of matrix of round robin of primary roles of CPU scheduling of algorithm resource sharing, sharing CPU and time across an overhead and medium dependency of quantum, and real life example of burst of saving of miss of customer, context switching of multi-threading. Okay, then save a screenshot and please note of notebooks. Okay, and okay, summary of key. That's overall three topics with their principle and real world and analogs. Thank you so much and share my video. Thank you so much.